For those of you who attended last month, you might remember that TJ and Morris spent some time talking to us about opportunities with biomass, and then specifically talking about one uh, potential technique in biochar. And Debbie Page Dumrose is here today to spend more time kind of doing a deeper dive into biochar. So that as a BFC, we can be more informed about kind of what opportunities it presents, ask lots of questions, understand that fully, and hopefully then talk about some of the potential implications of what that could mean for the Boise Forest. So Debbie, you should be good to go ahead and share your screen. If you have any challenges there, let me know.
I'm going to say you should be able to see it now.
You are good. Yep.
Yay. All right. So I started working on biochar about 14 years ago, mostly because I was trying to figure out a way, how could we limit the effects of slash pile burning on the soil and, reducing the impacts of burn scars and the loss of vegetation on those burn scars for sometimes decades. So let's see if I can get this to 1 minute here. This is what I want. All right. All right. I'm hoping you're seeing the next segment. So, there's been a lot of Rocky Mountain Research Station people working on this biochar piece, but we've also been working with our National Forest partners for a long time, just trying to figure out where, when, how, and why kind of things. So I do want to give a nod to all those folks who have helped us out. So today I'm going to kind of give you the big picture, why I think biochar has a place in forest management, why biochar is kind of cool, how to make it, mostly place-based, how to make it, and then talk about some barriers and opportunities. And I do want to, you might think that I'm kind of going fast, but I do want to leave time at the end so that we make sure we cover any questions that you might have. So you all know this, there's a threat to soil health, and it comes because of declining forest health. Climate change, insects, disease, drought, wildfire, all of those not only affect above ground, but also below ground productivity. I mentioned pile burning of this low value wood that we can't afford to ship any place. That pile burning impacts can be huge in some places. And overall, the loss of soil organic matter that leads to erosion and no vegetation. Oftentimes we don't have that sponge in the soil to hold water. And because we've lost organic matter. And so that means that we're not supporting the vegetation, or the vegetation is curing out earlier in the year and we can't keep it green. So, there's some different ways we can treat this non-merchantable woody residue. One is to leave it on site. There are economics associated with just leaving it on site, right? We have to pile it. It takes up valuable growing space for trees or other forest vegetation. As it decomposes, it off-gasses CO2 into the atmosphere. And there's been a little bit of research done on those class 4 and 5 logs in piles. As they decompose, they're also emitting nitrous oxide and methane. We could burn it. That's another easy one. Again, there are some economics associated with burning. It also takes up growing space, particularly if there are scars left behind. And there's emissions as the piles are burning, they're off-gassing CO2. But probably the worst part of the emissions happens when the piles are left to smolder and all that smoke is being emitted. And then there's biochar. There's economics associated with all of these, right? But the nice thing about biochar is that we can bring in local workforces. Conservation crews are a great way to get some of this work done. We can produce a valuable product, biochar, that could be used on site to rehab log landings, skid trails, mine soil. The way we create biochar, whether it's in slash piles or kilns or in char bosses or other air curtain burners, there are very few emissions that are moving out of this. So it's a great thing to use, particularly at the wildland urban interface or in campgrounds where there are people around. But in general, it's a nice alternative. Another tool in the toolbox, right? So why is biochar so great? You can see this little diagram. Biochar is pretty awesome. It's a charcoal product, so it's high in nutrient absorption. It can absorb heavy metals from mine tailings. It's great at not only holding water, but providing available water throughout the growing season. If there are other toxins like E. coli, for example, from livestock feedlots. It's great for that. We've started working with the Forest Service National Veterinarian and the Agricultural Research Service to see if biochar could be used to tie up chronic wasting disease. And we're still in the lab studies for that, but there's another tool that we could use to keep chronic wasting disease from killing off a lot of our deer and elk. So I mentioned water. Just increasing organic matter in the soil by 1%, we could store tons of water. This little graphic is, the amount of water that flows over Niagara Falls in 150 days. I mean, that's a huge amount of water. To kind of dial this down a little bit, biochar is great at building that sponge. We can decrease overland flow and increase water storage in the soil. There's been a lot of work done on different soil texture types and how much water, but I think it's pretty amazing to think about adding biochar to the soil and increasing water holding and available water by almost 40% for coarse textured soils. Even fine textured soils, a 15% increase in water holding and water availability could be tip us into having vegetation green into July and August instead of curing out in June. And of course, there's that carbon sequestration and climate change piece. Greenhouse gas emissions are growing. It's really nice if we can have another tool in the toolbox. And the nice thing about the carbon that we create for biochar is that it's stable in the soil for hundreds of years. And it's a rapid way to get carbon below ground. So I'm going to switch gears a little bit and talk about some ways to make biochar in woods. All of this is small scale, shovel ready opportunities. So the first one is just to do slash piles, right? Hand piles or equipment piles. And we've done work with these elevated piles, big material on the bottom, small stuff on top. And then we burn it. The key for biochar is to quench the fire when the flames go out. That creates the charcoal product so that all of that wood doesn't go to ash. It's also a nice way to stop that smoldering so we don't have as much CO2 going off into the atmosphere. And then we rake the biochar around on the site, and this is the Umpqua National Forest in South Central Oregon. Biochar on the lower left and no biochar on the upper right. This was in August, and we still had green grass on the biochar side. So we were pretty excited about that. It's the water holding capacity, but it's also being able to keep vegetation on site longer, right? And one of the things that the Umpqua had tried to do was to improve areas, meadow areas for wildlife forage. And we were able to keep upland sites green longer and had more vegetation for the wildlife. So you can also make biochar on site, right? This is the homemade variety of a kiln. Pretty easy to make. It's just corrugated metal. This farmer had put it on a gravel pad. We'd light it from the top, and then that creates a little flame cap on top, and it forces the smoke and particulates back into the flame. So we get a pretty clean burn. You can see a nice example of that flame cap. The nice thing about these kilns and the way we burn it from the top down, it means that we're building up coals on the bottom as we go, and those coals are protecting the soil. Here's a big box kiln. This was developed by Darren McAvoy at Utah State. It's double walled. It's about 12 feet long, 5 feet wide. We usually fill it with an excavator, you can see here, mostly because it's big and it takes a lot of biomass. You can see the pile of biochar in the background there. Usually it's a batch job operation, right? So we can do 2 batches a day in this kiln. The biochar in the back is from the first half of the day. Make another batch, you get a nice pile of biochar that looks like this by the end of the day. And then these ring of fire kilns, these are also double walled. So you could have conservation crews use something like this. It protects the crews as they get close. So it's not quite as hot. And then they can just throw the material in as the day goes on. The Flathead National Forest is using these double walled kilns along roadsides to take care of a lot of the slash as they clear roads. And they've got a conservation crew from the Flathead Valley that's working on these. And then air curtain burner. The Rocky Mountain Research Station worked with Air Burners Incorporated to develop the Char Boss. And what I'm going to show you in this video is the prototype. The second version is similar to this, but a little bit faster biochar production. We use a mini excavator to load it. You can see the air curtain is established over the top, so emissions are really low. Once that biomass breaks the air curtain, you get a little puff of smoke, and then the air curtain reestablishes and you're back in business. There's a hole in the bottom of the Char Boss, a slot, so the charcoal falls through onto a conveyor belt. And you can see on the backside of the unit, there's a little quench pan. So you keep that filled with water during the day and scoop out the biochar. Yeah, it's been a really great learning process for me about how to make biochar in this air curtain burner. But so now we've got the newer versions of this. We don't want to see that again. Okay. So now we got a newer version of this. The other opportunity for air curtain burners is the carbonator made by Tiger Cat. And instead of a drop-down system and a conveyor belt, this uses 3 augers to move the biochar out. So the water required for the Char Boss is about 200 gallons a day. The water required for this larger air curtain burner is probably in the maybe 500 to 800 gallons of water a day. It requires much more water. Sometimes the excavator will dig a hole for the biochar to fall into, and they just kind of create this little pond-like area for the biochar to fall into. So another option of being mobile. So the Char Boss you saw was on wheels. The newer version has 3 axles instead of 2, mostly because that conveyor belt's pretty heavy. But its best use is at log landings and on skid trails or campgrounds or parks, something that's relatively flat. This carbonator is on tracks and it can move across the landscape. Of course, there's a difference in cost, right? The Char Boss, last I looked, it was about $150,000. The carbonator is close to about $600,000. And this is the charcoal. I mean, charcoal all looks the same, right? From all of these systems. It's, in general, the biochar we get from the air curtain burners is about 1 inch minus material. So it's easy to transport to sites. So this is from the Mount Hood National Forest, and this biochar that they created, their first summer all went to mineland restoration activities. So it's nice to have some relocatable options. With the air curtain burners, we can use wet or dry feedstock, brush, trees, invasive species, and we're creating biochar continuously in both of these versions. We can do biochar in batch jobs with other air curtain burners like the Burn Boss, and it's just a matter of pulling the equipment away from the charcoal that's on the soil and then quenching it once you pull it away. So again, batch jobs. Nice way to make biochar as well. And there's a lot of folks using it that way. So uses for biochar, we could go on and on and on what the uses for biochar might be. Sorry about that. Let's go back. There we go. On forest sites that have an intact organic horizon, and we're just putting it out there to build organic matter in the soil, we put it on top of the organic matter. Couple of rains and it's moving through the organic matter, the litter's falling on top of it. And we see soil improvement, but it takes time, right? It's not a fast process. We did some work on the Bitterroot National Forest, and it took us 10 years to be able to detect changes in above ground tree growth. It only took us about 2 years to see differences in water holding capacity. So, it's a long-term process in forests is the bottom line. There's some work done on 3 national forests in in Region 9, so Missouri, Indiana, and Illinois, they are rehabbing log landings to build pollinator habitat. And they're mixing it in. So you can see them applying it in this picture. They just used a fertilizer spreader to put it on these log landings. But they had an excavator decompacting the soil, and then the biochar is applied and mixed in as well. You can also use it for growing native plants in nurseries. We've worked out, how much is good to put in with regular media that plant nurseries use. And this is the biochar spreader that the Forest Service developed. It's pulled behind a log forwarder. It's just a salt spreader that we put a cage around to protect it as this log forwarder wandered through the woods. We often have used it on log landings and skid trails to spread the biochar. But if the thinning operation leaves enough space between trees, then you could pull it all around the site. What we have found is that if there's an intact organic horizon, we see no impact on soil compaction while we're applying our biochar. So I want to talk about some barriers and opportunities now. About 2 years ago, we held 2 workshops. The Rocky Mountain Research Station held 2 workshops with land managers. One was in Colorado and one was in Montana, to just kind of get a sense of what were the barriers. What would it take to move the needle in terms of biochar production and adoption and use? And we heard a lot. One of the barriers has been this air quality permits. It's in some states, it's really difficult to get air permit. Oregon and Colorado are 2 of those. But the national EPA has been working on reclassifying these mobile units so they don't have to go through the Title V permit process. I have to say I've not been through the permit process in Idaho because all of the demos we have done have just been one-day demos, and we basically just tell the DEQ that we're going to do this. Oftentimes they come and watch to see what our emissions are, but I can't speak to the policy in Idaho about air quality permits. Another policy is, what do you use these slash piles for? Is it best to use it for biochar or bioenergy? Most places we can't transport the non-merchantable material to a bioenergy facility because it costs too much. So making it on site for biochar is really great. And Region 6 has developed contract language for allowing loggers to use the Forest Service air curtain burners and make another forest product, and they can sell it like saw logs. But some of that selling of biochar means that oftentimes if we're selling it to the public, whoever sells it would have to go through a registration analysis piece to make sure that we're upfront about what's in the biochar and what's not in it. Where do we go from here? Sometimes it's hard. National Forest managers told us it was hard to integrate another tool in the existing workflow because it had never been done this way before. There were novel equipment needs. There were training that needed to be done. We didn't have a comprehensive procedure for handling the feedstock. And it was unclear about where the agency and public and private support was. So right now we're in the process of finishing up this how-to general technical report that will give a lot of background on why we make biochar, but also all of these in-woods place-based biochar methods. How do you get started? What is the footprint? Where do you position the equipment to maximize the opportunity? What are the production rates? How much water do you need? All of that stuff. So we're making progress on this integration piece.
Sorry. Right.
And then economics is another piece. I've mentioned this before. We have to figure out the best way. Where is the slash located, and how do we move that to wherever the biochar is going to be made, and aligning that workforce piece with slash production.
Let me see if I can get a different computer. Pull up your
So yeah, lots of barriers, right? We could probably list more of the barriers than I have here on this list, but I think we're making some progress on all of the barriers. The equipment needs, we've got a lot of the equipment dialed in now. building that technical skill and figuring out how to build the workforce around that, I think are other opportunities. So biochar opportunities, let's talk about those. I think there's a lot of opportunities at the forest level, whether it's federal, state, or parks. We're reducing fuel loads, sequestering carbon. We get that soil health piece, building up the organic matter, and all of the things I mentioned previously about water holding, infiltration. We can reduce compaction. We did a lot of work with decommissioning roads on a couple of national forests and using biochar as one of the ways to keep the soil from recompacting after we decompacted it. Opportunities all abound. We're doing the restoration thinnings, the salvage logging, the harvest operation, and we can then build into that, maybe moving that biochar for close by mine site restoration. There have been a couple of places where biochar created either on site or at fixed plants has been redistributed for agricultural use, because a nice way to get a really wonderful compost is to put the biochar into feedlots and then get it mixed in with all of the nutrients and the moisture in the feedlots, and then using that as part of a compost blend for organic farming. And the nice thing about putting the biochar out is that it reduces the need to irrigate as much. So that could certainly be a benefit in the future. Air permits. We've done a lot of testing. We've worked with the Fire Lab in Missoula, and we've done some work with the U.S. Biochar Initiative in Oregon. We've built hoods to capture emissions. We did this work in Oregon because that's been one of the places that have been strict on air permits. The Oregon DEQ was really excited to see the results of the emissions test, because there were so few emissions, lower than what they had thought from these air curtain burners. So that was a nice way to give them information to help them realign their permit procedures. And a lot of it is just the education piece and doing demonstrations, showing what the equipment can do or what you can do in a kiln and how few emissions there are. So this work that we did in Tooele, Utah, was in a garbage dump, but it was where they were taking all of their yard waste. And so we were using the yard waste in this testing. We had the big box kiln, the ring of fire kiln, and the char boss all lined up. We were using the same feedstock and got all of the emissions testing done in a week. And I haven't seen that data yet. It's still coming from the Fire Lab, but yeah, as soon as that's available, I'm happy to share that. Other opportunities are building, it's already built into the bipartisan infrastructure law. We've got several, research has several biochar related projects funded with mine site restoration. The biochar that comes through the char boss has been, because it's hot coal quickly quenched in that quench pan, has been really great at absorbing heavy metals. And so we're trying to figure out which biochars are best suited for individual heavy metals like mercury or cadmium or whatever it might be. The wildfire crisis strategy also aligns with this fuel reductions opportunities and what do you do with this material. We're doing increased monitoring and reporting about carbon sequestration. And so that there's another opportunity to be able to build in some of these tools. We've got lots of supply, right? Back in 2016, it was estimated that there were 350 million tons of biomass per year in slash piles. So that's thousands and thousands of piles. We can increase accessibility to these slash piles by using the fixed and the mobile units, or just taking care of stuff at roadsides. The nice thing about all of these tools for place-based biochar production, except for slash pile burning, is that the fire is contained, and so the chance of escape is minimal. We have very few embers that come out of those air curtain burners, and so it's nice. You can extend the burn window to start, to continue to take care of a lot of this wood at roadsides or within forest units. And we have demands for sustainable harvesting and carbon sequestration, building up that forest and soil health. And, on non-federal lands, there's an opportunity to take advantage of carbon renewal credits. So that's a nice bonus. The NRCS also has an opportunity to pay landowners to use biochar on agriculture and forest sites. And so, again, non-federal landowners can take advantage of biochar that way. And the Washington State Legislature is working on changing their air quality permitting system. They had, in their bill, had found that the use of distributed small-scale biochar production units for forestry and ag waste was consistent with their forest restoration goals. And it was an integrated strategy that helped reduce greenhouse gas, produces this durable carbon storage, and minimize air quality impacts. And I mentioned earlier that the National EPA was also working to change their Title V permitting requirements for air curtain. They're called incinerators, but when they burn wood waste, clean lumber, and yard waste, then it's an opportunity for us to take advantage of these new permits that we hope will take place. The National EPA, I think, have listed this change in the Federal Register. We don't expect to see a change until probably March or April. And then these carbon renewal credits. We have done a life cycle analysis of the CHARBOS, and with the creation and subsequent application of biochar to the soil, we figured it could generate about 2,000 megatons of CO2 equivalent reductions, certificates in a year. So nice if you're a private landowner to take advantage of these carbon renewal credits. And I mentioned this before, this economic development piece. It's nice to be able to get young people involved in natural resources and get them excited about making a change. And we've worked with a lot of these conservation crews with ring of fire kilns or the big box kilns. And it's really nice to talk to them about, forest management, treat the backlog of woody debris, support jobs, talk about climate change and how they're helping to mitigate climate change. It's a nice story, and it's a great way to, to at least get young people in the woods and working on some of these projects. And the Forest Service in their Carbon Partnership Program also talks about biochar action plan. As they mentioned in this Carbon Partnership Program, it's a great cross-sector opportunity to reduce wildfire risk, reduce the negative effects of pile burning, improve soil, sequester carbon. And the nice thing about it is that these biochar projects have, it's easy to measure how much carbon you've created and how much you're putting in the soil. So yeah, it's nice to have them on board with this. And this was in the action plan from 2022. Biochar products are among the projects realistically ready for robust accounting and rigorous claims of climate benefits. So we're moving the needle. We at the Rocky Mountain Research Station have been engaged in this since the very beginning, to develop the technology, to build some science communication pieces that I've shared with Morris and I think are on your website. The permitting process, we've been trying to provide data for this permit process. We're helping to build markets for how do you make biochar, how do you sell it? And we have a lot of case studies and research sites that are can talk about where we're doing our work. A lot of this, we've tried to move towards this biomass utilization campus idea where all of the woody biomass, from twigs and needles all the way up to saw logs, are moved to one location, sorted at that one location, and all of the revenue streams are taken care of, and at the end you still have biomass that has no value. Convert that into biochar. And I can't leave you without talking about healthy soils, right? I said this at the very beginning. We are really excited about being able to make biochar on site, produce this high carbon product that lasts for centuries. We have seen improvements in all sorts of chemical, physical, and biological properties in the soil, and so it's kind of nice to be able to see this within a couple of years of applying the biochar to study sites. How much to add? We found that the best results are at 10 tons per acre. So, anything less than that is great. we found that a lot of forest sites get overloaded if we put more than 10 tons per acre, which is about 2 to 3 to 4, depending on how chunky the biochar is, 2, 3, 4 inches deep. Any rate sequesters carbon in the soil for a long time. We have also found, though, that on abandoned mine soils, more than 10 tons per acre might be needed to build back. Sometimes those mine sites are so degraded that it's just hard to build organic matter quickly. But biochar is a nice way to do that, and so we've used more than 10 tons per acre. What's going on the Boise National Forest? We are engaged with the forest at the Missouri mine site to restore degraded soil, reduce erosion. This is a funded project through Bill and some targeted allocation funds that a couple of us at the Rocky Mountain Station have gotten. The problem with mine soils and a lot of agricultural soils is that they have a very low pH, and this limits oftentimes below ground biomass of fungi and bacteria, but it also limits plant growth. And so biochar is usually, at least our forest biochar is generally around 7, 7.5 to 8. And so it helps bring the pH of the soil up and helps to foster some better plant and microbial activity. There a lot of other sampling has been done at this Missouri mine site, but yeah, I don't want to overload you with data, but know that that's going on the Boise. Probably you already do. Another is a future opportunity for biochar research at the Boise Basin Experimental Forest. There's a group nationwide who are doing some landscape scale harvesting, and I think there are 3 ecosystems on the Boise National Forest that will get I think 3 different thinning treatments. So this is a way to integrate the char boss into removal of that biomass that's result of the thinning operations. You could do it, as the green material is coming down from the logging site to the log landing. We just throw it in the char boss, or wait a couple weeks and throw it in the char boss, however it works out. But that's one of the things that we don't have a good handle on in a lot of places is, how can we integrate this into an ongoing harvest operation? We know we can burn wet and green biomass. We just need a good base of coals in the char boss, and then we can get started that way. But yeah, it's a nice opportunity. What do you need? You need 2 to 3 people who want to learn how to run the char boss, scoop the charcoal out of the quench pan, and run an excavator. And you need a water truck. So yeah, we're happy to teach people how to run the char boss and loan ours. We're going to loan our Idaho char boss to the G-Mug National Forest. They're doing some thinning. We're going to make the biochar on site, and we're going to use that for mine site restoration. So I think that'll be a nice way to integrate that whole process in Colorado. And so again, ecosystem services. We've talked a lot about the soil benefits. It's also great for purifying drinking water. It's like adding a charcoal filter to your soil. Clean water, I think that's one of the huge ecosystem services we can claim from national forest lands. Building pollinator habitat is a great way for places that are close to agricultural fields. Take those log landings, decompact, put in the biochar, build some pollinator habitat, so for plants and insects. And of course, we always talk about this wildfire risk reduction. So we're reducing the number and volume of piles that are out there in the landscape. And so I want to end there. I know I went through a lot of stuff pretty quickly, but I do want to make sure that we have time to answer any questions that you might have. So I'm going to stop sharing so I can see you all.